Good morning, Brynn. I thought just capturing this as a video and uploading it to YouTube would be a lot easier for me than to try to type up my explanations, and I think it'll be better for you. The first question you're asking about is number 3, where you have rectangles that are going to be formed. If I had to retype this question, I would add a little bit of something to it to make it clearer. The question is how many different rectangles can be formed, and it should say by 8 different horizontal lines and 3 different vertical lines. The key idea here is that a rectangle is a 4-sided figure where the opposite sides are equal in length. So if we're going to construct a rectangle by arranging these pieces, then what I need to do is I need to pick 2 of these horizontal lines and I need to pick 2 of the vertical lines. And once I've picked those lines, I get a particular rectangle. And what that means ultimately is of the 8 horizontal lines, you need to choose 2 of them to form the long sides of the rectangle, the way I've drawn it. And of the 3 vertical lines, you need to choose 2 of them. So whatever 8 choose 2 multiplied by 3 choose 2 is going to give you the answer to this first question that you asked about. The next one you asked about has a subcommittee that's going to be formed out of a group of people, athletes. There are 15 athletes on this athletic council. 6 are female and 9 are male. And we want to choose a group from those 15 people that have 6 people in the group. And the question is, how many different ways can a subcommittee consist of at most 1 male? What at most 1 male means is no more than 1 male. So what are the possibilities? If we cannot have more than 1 male, you could have a committee with 0 males or 1 male. You cannot have more than 1. So the only possibilities are you have 0 males or you have 1 male. Now, if you have 0 males, you must also have 6 females because we need 6 people in total on the committee. And if you have 1 male, you also need, which means and, 5 females. So we have to bring the total up to 6. And all we're going to do is use our combination notation to write out what this answer would be. 0 males and 6 females would be, well, let's see, we have 9 males and we need to choose 0. And means multiply. We have 6 females to choose from, and we happen to want all 6 of them. So the number of committees that has 0 males and 6 females will be 9 choose 0 multiplied by 6 choose 6. Then we have the word or, which means add. Now, how many ways can we select 1 male and 6 females? Well, there are 9 males to choose from, and you're choosing 1, and there are 6 females to choose from, and you're choosing 5. So the number of committees, subcommittees that have 1 male and 5 females would be 9 choose 1 multiplied by 6 choose 5. So just to make sure you're catching my drift here, this is how many committees have 0 males and 6 females. This is how many committees have 1 male and 5 females. So what you're going to do is you're going to add this all together. This total here, whatever this number is, will be the answer. And I'll leave it up to you to actually calculate that. All right, number 5, you are going to be choosing 11 basketball players out of a pool of 17. And A says Colin and Daryl, who are inside of that pool of 17, must be selected. Now, let me show you a very clinical way of doing A, and then I'll show you how I would kind of reason it out in my head. Rather than talking about 17 people, I'm going to talk about 1 Colin, 1 Daryl, and 15 other people. So if we want 11 players and Colin and Daryl must be selected, then of the pool of one Colin, you need to choose that one Colin. And of the pool of one Daryl, you need to choose that one Daryl. And of the pool of 15, you need to choose 9 more players because you need 11 in total. And I'm going to actually calculate this because I want to talk about a slightly different way to imagine what's going on with this question. 1 choose 1 is 1, but I will include it in my calculation. So we have 1 choose 1 multiplied by, for Daryl, 1 choose 1, multiplied by, for the 9 other people, 15 choose 9. I want to make sure that I've entered that right before I hit enter. And it looks okay. So there are 5,005 different ways to select the 11 players where Colin and Daryl must be selected. So the answer to that question is 5,005. What I would have done here, Brynn, is I would have simply just said this in my head. Of the 17 players, Colin and Daryl are already guaranteed positions on this squad, which means I don't even need to worry about them. I just need to worry about saying I need to choose 15 players. Sorry, I need to choose 9 more players out of 15. So I wouldn't have included this 1 choose 1 and 1 choose 1. I would have just said, well, of the 15 remaining players, I need to choose 9, and 15 choose 9 will give you 5,005. Now, question B is a really sneaky question. Question B says that you're going to pick the 11 players. Jeff and Brent cannot both be selected. Well, what does that mean? Does that mean that neither one of them can be selected? No. It means we could have Jeff selected and Brent not selected. Or we could have Brent selected and Jeff not selected. As long as they're both not selected. But there's a third possibility. There's another way they can not both be selected, and that's if neither one of them is selected. So if Brent is not selected and Jeff is not selected, then that would satisfy the condition of the question, which says they cannot both be selected. So as I go through these calculations, because we have the word or in a couple of places and we have the word and in 3 places, we're going to be using the and equals times and or equals add. I'm going to break up the 17 players into 1 Jeff, 1 Brent, and 15 others. All right, so how many ways, I'm going to do the first line first, where I have Jeff selected and Brent not selected. How many ways can that happen? Well, if Jeff is selected, I need to choose 1 out of the group of Jeff. And if Brent is not selected, what I need to do now is say that of the 15 other players, I need to choose 10. I need 11 people selected in total. So if Jeff is already selected, I need 10 more. But I'm going to pick those 10 out of the group that Brent is not in because Brent can't be selected. And then we say or, and now I'm going to look at this line here where Brent is selected and Jeff is not. Well, if Brent is selected, I need to choose 1 Brent out of the group of 1. And if Jeff is not selected, then the remaining 10 players for the squad are going to be chosen out of the 15 people that don't include Jeff. And then we have another or. If Brent is not selected and Jeff is not selected, then the bottom line is we need to choose 11 players out of the group that does not contain Brent and it does not contain Jeff. So again, this is saying we have to select Jeff and we have to select 10 other people that do not include Brent. This is saying we have to select Brent and we need to select 10 other people that do not include Jeff. This is saying we need to select 11 people out of the group that does not include either Brent or Jeff. And if you add those numbers up together, 1 choose 1 times 15 choose 10, plus 1 choose 1 times 15 choose 10, plus 15 choose 11, you're going to get the right answer. Number 6, an all-night showing at a movie theater consists of 5 movies, and we're going to pull those movies out of a pool of 10 disaster and 4 horror movies. Now, there is a bit of a problem with this question, and it's that the word schedule is probably a bad word. I'm going to change the question to how many groups of movies. Because in my mind, the word schedules is telling me that order is important. And order is not important. That's not the intention of this question. The intention of the question is how many different ways can you pick the movies? So what does at least 4 disaster movies mean? Well, it means 4 or more. You know, if you have to be 18 years old to get into a club, that means you will get in if you're 18 or more. If you have to be at least 18, it means 18 or 19 or 20 or 21, etc. So 4 or more means 4 disaster movies or 5 disaster movies. And I'm not going to go further than 5 because it says that the all-night showing at a movie theater is going to contain 5 movies. So I can't have 6 disaster movies because we're only allowed to have 5 in total. This is kind of similar to the question we did earlier with at most 1 male, although that was at most and this is at least. If we have 4 disaster movies, we also need 1 horror movie. And if we have 5 disaster movies, we need 0 horror movies. These numbers have to add up to 5 for each selection. So 4 disaster and 1 horror, or 5 disaster and no horror. And we're just going to piece this together with the combination notation. 4 disaster movies would be 10 choose 4. Multiplied by 1 horror movie, there are 4 horror movies to choose from. We're going to choose 1. Or that means we add 5 disaster movies. Well, we have 10 disaster movies to choose from, and we're going to choose 5. And we have 4 horror movies, and we're going to choose 0. I wrote down a lot there, so I'm just going to step back and look at it. Give me a second to make sure that everything is correct. Yeah, I think that's fine. So whatever this number equals, this will be the answer to the question. And again, it's kind of a poorly worded question because they had the word schedule in it, and schedule implies order, but that wasn't the intention here. All right, I think we have one more, and you had asked how to do this one algebraically, and there isn't a way to do this algebraically that doesn't require a vast amount of work. And I'm not just saying it's going to take you a half hour to do it. It would take you hours. The algebra just gets worse and worse and worse. The intention here is the following, that when you have 28 choose 7, you get a number that's the same as 28 choose some other number. And what you did was you calculated 28 choose 7, I'm assuming, and you put it in for y2, and you put 28 choose x in for y1, and you found out where they were equal. But the idea is this. The answer, and I can tell this without even looking at the answer or looking at any other work, the answer is x is going to be 21. 28 choose 7 and 28 choose 21 will be equal. You need to make a note that the 7 and the 21 add up to get 28. So if we have 28 students in a class, and I say that I'm going to pick 7 of them to take out for ice cream, what I do is every time I choose a group of 7, I leave behind a group of 21. So for each group of 7 that I choose, there is an identical number of groups of 21 that are chosen not to go for ice cream. So whatever 28 choose 7 is, that's the number of ways I can pick 7 people to go for ice cream. But for each of those ways to take 7 for ice cream, there is one way to leave 21 behind. So the reasoning is that as long as these two numbers that are highlighted add up to give the total you're choosing from, they will be equal numbers. So I hope that makes sense. You might have to give this one a little bit of thought. And I hope that all of that made sense. If you have any questions or you need clarification with any of these, just fire off an email to me and I will see what I can do. Have a great day, Brynn. We'll talk to you later.